In this video, we're going to do everybody's favorite thing, word problems. The nice thing about this word problem is we have the statement of the problem, I have the variables defined, and I already have the system of equations set up. On the next two examples, we're going to need to define variables and come up with the equations. So take a look at how I set the equations up though. If I defined x as the price of an adult ticket and y was the price of a child's ticket, if we look at the first sentence, the ninth graders sold 220 adult tickets. That's where the 220x came from in the first equation, and 100 children's tickets. And they took in 410. So I took that first sentence and made it into a math sentence, the first equation. The second statement that includes things that show up in my equation is where the 10th graders sold 180 adult tickets and 120 children's tickets, and they took in 366. Those English sentences became the second math sentence. Now let's go ahead and solve this. If I want to solve this equation, what I need to do is figure out what I would like to eliminate. And this one might be a little bit harder to figure out what to eliminate. If I look at my x's, I have a 220 and I have a 180. I can't say that I really count by 220s or 180s very often. So that one seems like it might be a little harder to make those cancel out. If I look in the y column, I see a 100 and a 120. I can count by 100s really easy. 100, 200, 300, and so on. Counting by 120s isn't that bad either, because we'd have 120, and we'd have 240, and we would have 360, and we would have 480, and then we would have 600. So I could turn that 120y into a 600y. I could also very easily turn the 100y in the first equation into a 600y. So I think I'm going to cancel out the y's. I need to make one of those y values positive 600, and I need to make the other negative 600. I'm going to make the top one the positive 600 just because. And so that means that I'm going to multiply this top equation by positive 6. And I'm going to multiply this bottom equation by negative 5. I'm going to get some big numbers here. And this is really the perfect problem to use a calculator for. So let's go ahead and see what I get when I multiply these equations. If I take everything in my top equation times 6, I'm going to have 1,320x plus 600y equals 2,460. And if I take everything in my bottom equation times negative 5, I get negative 900x. And I get negative 600y. And it's going to be equal to negative 1830. Total calculator problem here. Let's add these two equations together. If I add a 1320x and a negative 900x, that gives me a 420x. If I add together a 2,460 and a negative 1,830, that gives me 630. This is a one-step equation that I need to solve. I need to divide both sides by 420. And if I divide both sides by 420, I would end up with 1.5, which, since we're dealing with money, we might as well think of that as $1.50. So I'm halfway done. So the next thing I need to do is decide which equation I would like to plug x equals 1.5 or $1.50 into. I think it's probably a toss-up. I would probably pick the bottom equation because it has smaller numbers, and that's the only reason that I would pick the bottom equation, because it has smaller numbers. So let's plug $1.50 in for x in the bottom equation. So my bottom equation would be 180, and instead of x, it's going to be times $1.50. I'm still going to have a plus 120y, and it's going to be equal to 366. So this is a two-step equation that I have to solve. Using my calculator, if I take 180 times 1.50, I get 270 plus 120y equals 366. These are just like equations we've solved this whole time, except they have bigger numbers. This is a two-step equation. I'm confident everybody can solve this two-step equation. I would have to subtract 270 from both sides. And when I subtract 270, I would have 120y equals, and if I take 366 minus 270, I get 96. And then if I divide both sides by 120, I would end up with y equals 0.80. So at this point, once I have y equals 0.80 and x equals $1.50, let's go ahead and write down our conclusion. Remember, x stood for the price of an adult ticket, and y stood for the price of a child ticket. So let's write our conclusion in a complete sentence. So I will write an adult ticket is $1.50. And a child ticket is 80 cents. And so that would be changing our math sentences, y equals 0.80 and x equals $1.50, into an English sentence based on what I define the variables to be at the very beginning. In this problem, I would like to go through this word problem, change everything in here that's an English sentence into math sentences, and we are really just going to set up this problem. We're not going to actually solve it like we did number one. We're just going to set this one up. But I do think the hardest part is setting it up. So the gist of this problem is that you're going over sales receipts. There 240 pairs of shoes were sold, and Nikes sell for $66.95, Vans sell for $84.95. The total receipts were $17,652, so that was probably a pretty good week. And the cash register was supposed to keep track of the number of each type sold, but it didn't. So we can use a system of equations to find out how many of each type were sold. I realize Nikes probably cost more than Vans, but we're just going to go with what I have set up. First thing I need to do is decide what my variables are. There's two things I don't know. I'm selling two different pairs of shoes, so I'm going to have an x equals and y equals. I'm going to let x stand for whatever comes first, and I see Nikes came first. I'm going to try and be as specific as I can. So I'm going to let x be the number of pairs of Nikes sold. And I'm going to let y be the number of pairs of Vans sold. So that's defining my variables. Now the next thing I need to do is start setting up two different equations. One of the equations is going to incorporate this 240. 240 pairs of walking shoes were sold. I think that one's the harder one to set up, so let's do that second. The one that I think is easier is the one that incorporates money. Nike sells for $66.95, Vans sell for $84.95, and we brought in $17,652. So I'm going to put everything that deals with money together. So I bring in $66.95 every time I sell a pair of Nikes, so that's X, plus I bring in $84.95 every time I sell a pair of Vans, equals the total, $17,652. So I have money, money, and money. $66.95 is money, $84.95 is money, $17,652 is money. Let's set up the one that now incorporates the 240. Something has to add up to 240. This is the one that I think is tricky, but we have to look back at what our variables were. 240 pairs of walking shoes were sold. That means the number of pairs of Nikes that got sold plus the number of Vans that got sold was 240, because we're calling them both walking shoes. So the equation for this one is x plus y equals 240. And these two equations together would be the system of equations for this problem. If I needed to solve it, then I would have to decide if I want to solve it using elimination or substitution. Let's take a look at this last word problem and change these English statements into math statements. Taco John's had a special this week. At noon on Saturday, they sold a total of 23 entrees at a total cost of $66. All the entrees were either $2 tacos or $3 burritos. How many tacos and how many burritos were sold? First thing I need to do is define my variables. And in this problem, I don't know how many tacos and how many burritos were sold. I'm going to let X stand for the number of tacos, since that came first. And I'm going to let Y equal the number of burritos, because that came second. All right, now let's try to set these up. I think I'm going to do the one that deals with money first. We have $2 tacos, $3 burritos, and $66. So money, money, and money goes together. $2 for a taco, 2x, plus $3 for a burrito, 3y, equals 66. The one that I think is the hard one to set up is that they had sold a total of 23 entrees. That means the number of tacos plus the number of burritos has to equal 23. Now, once I have these variables defined and these two equations written, I have now set up this system of equations problem.